All right, this video is going to go over conic applications for word problems. So let's go ahead and get started. Look at this first one. They are giving you the equation. Now, if you wanted to make that equation look like an actual hyperbola equation, you could divide all of these by 15. And it would look somewhat, it would equal 1 and be like what you're more familiar with seeing. But you don't really need to do that for this problem, because what's going to happen is they tell you that this length, A, is 9, okay? And they want to know this right here, this height. Well, they just gave you the equation for this blue curve, right? So to find this green height, you just imagine a coordinate right here, an XY coordinate. And you know what the X is, it's 9. So you just have to go solve for Y. So you just take this equation and plug in 9 for X. So it'd look like this, Y squared minus 9 squared equals 15. Y squared minus 81 equals 15. Y squared equals 96. So Y is the root of 96, which is like 9.8. And meters, because that's what we're referring to here. So the height of that green wall is 9.8 meters. Okay, let's look at the second one. They're telling me there's like some hyperbola with a diameter of 60 feet at the center. Okay, let's just imagine a hyperbola. And there's a diameter of 60 feet at the center. Well, what that means is from center to vertex is 30, right? Well, that's also your A value. So A is 30. All right. And then they tell me the distance between the two foci. So there's two foci here. This total distance from green dot to green dot is 98. So that means halfway, half of that, this distance, is 49. Well, that's your C value because it's from center to foci. So I know what A is and I know what C is, and all they're looking for is an equation. So I need to go get B. On a hyperbola, it's A squared plus B squared equals C squared. We knew A was 30. We don't know what B is. And we knew C was 49. So if you do this, you'll get 900 plus B squared equals 2401. So B squared is 1501 when you subtract that 900. And I don't really care what B actually is, because I'm going to be writing an equation for a hyperbola, and it's always A squared and B squared anyways. So I'm going to end up squaring it back anyways. So my equation would look like this. This is a horizontal hyperbola. So X squared here, Y squared here. Now we knew A was 30. So I almost wrote 30 there, but it's actually 30 squared. Remember, it's A squared in the equation, so 900. Hyperbolas have a minus in the middle. And then we just found B squared as 1501, so that's what would go here. Because here's A squared and here's B squared. So this would be my answer, this equation. Okay, this third one. They give me the equation for a hyperbola, and basically by doing that, they tell me A is root 2, and they tell me B is 2. And so they want to know how close the sun is, this green dot in our picture, to the vertex, to this red dot. All right, so the first thing we need to do is we got to go find this whole value of green, this distance. That's C, because it's from center to foci. And so you would run A squared plus B squared equals C squared. So A squared was 2 plus B squared was 4 equals C squared. So C squared equals 6. So C equals root 6. That's this whole green distance. This green distance over here is root 6. But that's not what they're asking for. They're asking for how close is the sun to the vertex from green dot to red dot, aka this blue distance right here. So what you do is you take the entire green distance, which is root 6, and you subtract this red distance, which was A from center to vertex. So minus root 2, and this is what it actually would be. So this has a value of 1.035276, right? But then they say we're talking about in terms of millions of miles. So you have to multiply this by 1 million. So you end up getting 1,035,276 miles. This would be my answer. Okay, number 4. There's this rectangular board. Okay, imagine a rectangle. They want to cut an ellipse from it. So an ellipse is being cut from it. Okay, they tell me that the length it's 12 by 11, this board, which means from center, we're going half of 12 and half of 11. Okay, now they want to know if we had 2 foci, at least this is the way I interpreted this problem. I might be wrong, I don't know. But they say after the foci are located, a string is connected to them and pulled by a pencil, and they want to know the length of the string. So they want to know this green distance, okay? So the first thing we need to do is we need to get this blue distance, which is C. You need to go find C. And so the way you do it is you've got a squared minus b squared equals c squared for an ellipse. Well, we knew a was 6. We knew b was 5.5. And so we can just do this math right here, and you'll get c squared equals 5.75. So c is the root of that. It's like roughly 2.4. That's this blue distance. But they want green, which is double that distance. So I would take this and I would times by 2, and I would get 4.8 feet. That would be my answer. I might have interpreted that one wrong, but that's how I would have done it. Okay, number 5. Technical difficulties. All right, number 5. It's another rectangular board, and they're cutting an ellipse out of it again. All right, and they tell me that it's a 16 by 20, so 20 feet by 16 feet, which means from center we go 10 this way, that's my A, and we go 8 this way, that's my B. Okay. And they're saying, how far from center of the board should the foci be located? So they want to know where these green dots are going to be. And so you need to go find this distance right here, which is C. All right, so all you do is you run it through the a squared minus b squared equals c squared. You knew a was 10. You knew b was 8. So it's like 100 minus 64 equals c squared, which is 36, which makes c equal to 6. And so the distance, they say, how far should the foci be? Well, that distance, green distance, 6 feet. 6 feet. Okay. Moving right along. Next, there's this microphone has a parabolic cross section. Okay, if I see that parabolic, that word, I draw a parabola. And I'm generally going to draw my parabolas vertical. And if it's a vertical parabola, it uses the equation x minus h squared equals 4p y minus k. All right, well, if you're calling your zero or your center 0, 0, you can really refer to this equation as x squared equals 4py, because it's just going to be like minus 0 in there anyways. Okay, now let's add some numbers. They say the cross section, this entire green distance is 20, which makes half of that distance 10. Okay? Now, also, they tell me that the focus is 9 inches from the vertex. So this right here is 9. And what that red tells you right there, it tells you your p-value is 9. Because remember, your p-value is the distance from your vertex to your focus. So I know what the p-value is. And they basically want to know this height right here, this blue height. So what you do is you call this a coordinate, x comma y. We know that if we're calling this black dot right here 0, 0, then we went right 10. So my x is 10, but we don't know y. So if you look at this equation, we know what x is and we know what p is, but we don't know what y is. And so we can solve this pretty easily. We're calling x 10, so it's like 10 squared equals 4 times our p-value was 9 times y. So it's like 100 equals 36y. When you divide that, you're going to get, as a fraction, you would get 100 over 36, which is reduced 25 over 9. So you could probably leave it like that. You could also make it a decimal if you wanted, but basically that's that blue height. That's this blue height, aka the depth of the microphone. That's how deep it is. And so they're talking in terms of inches here. Okay. Moving right along. We are on number 7. There's a cross section of a canal, and they say it takes the shape of a parabola. So I instantly draw a parabola. Okay, if the surface water is 40 feet wide, so again, they're giving us this entire thing of 40 feet, which means from center, it's 20 feet. Okay, and they also tell me the canal is 20 feet deep at center. So from center, this red line, they're telling you is 20 feet deep. And they want to know how deep is the canal 18 feet from the edge. So imagine like right here, let me do it in blue, somewhere like right here. They want to call 18 feet from the edge. So if you think about this as an XY coordinate, you know the X is 18, and they're looking for the Y. They're looking for this green height. Okay. So the first thing I'd realize is this right here has a coordinate 20, 20. Okay. Now I'd also realize that parabolas use, if we're calling this 0, 0, then it would be x squared equals 4p y. Like that. Okay. The first thing I'd do is I would take this 20, 20 as an x and a y, and I would plug it in. That way I can go find the p-value. So you get 400 equals 80p. Divide and you get your p-value equal to 5. Now, this is a very big piece of information because now I know my overall equation is x squared equals 4 times 5 times y. And so I can find any like xy combo now. Well, now I would go back to the blue here and I'd plug in 18 for x and I would solve for y. So you get, I think that's 324 equals 20y. If you divide, you get 16.2. And they're talking in terms of feet. So that is this green height. You had to go get your p-value. That way you could have a main equation. That way you could plug in just an x value and solve for a y value. Hope that made sense. Okay, let's keep moving. We're on number 8. They say this satellite dish has a parabolic. That word, boom, I instantly draw a parabola. Okay. And they say it's 6 feet deep. All right, so this is the shape it takes, and they say this right here is 6 feet. All right, now the focus is 16 feet from vertex, so it's like here somewhere. This whole thing is 16 feet. Well, that red right there tells you your p-value because it's from center to focus. And they want to know the width of the satellite dish at the opening. So we knew blue. They want to know green. So what that means is you're going to have to make this an XY coordinate where the Y value is 6. And you're going to use your default equation. Remember, we're calling this red dot our center at 0, 0. So x squared equals 4py. All right, we know the p value and we know the y value. We don't know x value. So I would be x squared equals 4 times p value is 16 times this y value is 6. If you do this, you're going to get x squared equals 384. When you root that, it's like 19.6. All right, so that's in feet. That's this green line right here. But you also need to realize that's only half of the width of the satellite dish at opening. The satellite dish looks like this, and the width of it would be this full amount. We only got this green amount, so we have to double it. And so my final answer is going to be 39.2 feet. It would be this total pink line, the total width of it at the opening. Okay, let's keep moving. We're on number 9. I'm going to try to move the screen down. All right, good. Here we go. They say this building has parabolic arch. So I usually would draw this, right? But if it's a building and it's an arch, uh-oh, my undo is not working. That's okay. I'll just erase it. If it's a building and it's an arch, if you think about it, well, then it's going to be probably pointing down like this. All right. So we need to call our center here 0, 0. Okay. This arch is 8 feet high and 34 feet wide at the base. So this full distance is 34 feet, meaning cut in half is 17. Okay. And this height, okay, it's not really to scale, that's okay, is 8. All right. So what you need to realize is they just gave you this right here as a coordinate, 17 feet to the right, so 17, and 8 feet down, so -8, like that. They want the equation of a parabola. So this one, it's x squared equals 4py. We knew x is 17. We don't know our p-value, but we know y is -8. So if you do this, you get 289 equals -32p. And so your p-value is 289 divided by -32. All right, so your equation is going to be x squared equals 4 times your p-value, which we just found, 289 over -32 times y. And then I would just simplify it a little bit. X squared equals, I'd multiply this out. I'd probably keep it as fractions. So it'd be -289 over 8 and then y. This would be my answer. Okay, next page. Number 10. I don't know why this is still here. All right, there's this railroad tunnel and it takes the shape of an ellipse. So it actually kind of takes this shape, right? They give me all these numbers and they want to know the equation of the ellipse. Well, the first thing I'd probably do is I'd realize that this is a horizontal ellipse. And so your equation is going to be x squared over a squared plus y squared over b squared equals 1. Okay? Now, I need to go find A and B in order to do this. Well, they tell me, change colors here, they tell me that A is 8 feet. So this right here. Okay, I paused it for a second and I was thinking about this. No, I wouldn't approach it that way. What I would do is I'd realize that there's this arch, right? And they're actually, when they give me this information right here, they're telling me a coordinate, an XY coordinate. So 14, comma 18, okay? And so what I would do is I would be plugging that in for X and for Y, but I still need either A or B. Well, they tell me the height of the tunnel at the center is 28 feet. This entire height from center. See, I don't think like this right here was talking about from center, so I'm just kind of going to ignore that that graph. So this blue line is 28 feet. Well, that's going to be on a horizontal ellipse. That's your B value. All right. And so I would plug in all this information. So it'd look like this: 14 squared over a squared plus 18 squared over b squared, which we said was 28, equals to 1. And I'd be solving this equation. So if you do this part, I think you get like 0.25 or something. Or 1/4. So subtract that. So it'd be 3/4. I'm just going to keep it decimals for this one, 0.75. And so now you can basically cross multiply this. $14 squared is 196. And then I would be dividing by 0.75. So I'd get a squared equals 432. And I don't even need to know what the root of that is because what they're looking for is an equation. So my equation would look like x squared over that 432 that we just solved for, plus y squared over, we knew b was 28 squared, which was, or b squared is 28 squared. So that's 784, and it equals 1. This would be my equation. This is very misleading. I wouldn't look at that. Okay, number 11. There's a elliptical riding path that they're building, okay? I did it as a horizontal ellipse. You could probably do it as a vertical as well, but I pictured this rectangular piece of property and they're making an ellipse on it. So, okay, that's not a very good ellipse, but that's okay. And they tell me that it's 6 by 4. So we're going to call this 6 and we're going to call this 4, which means from center, this distance is 3, which is your A value. And this distance is 2, which is your B value. And if they're just looking for an equation, well, that's just x squared over a squared plus y squared over b squared equal to 1. So just plug in a and b. So you'd get x squared over, a was 3, so squared it's 9, plus y squared over b was 2, so squared it's 4, equals 1. That's what I would have done for this equation. Okay. Now number 12 is cut off with the pictures and stuff, so I'm just going to kind of ignore it and jump right to number 13. Okay, there's a dolphin jumping out of the water, and it takes the shape of a semi-ellipse, so like half of an ellipse, like this. If the full ellipse, it would look like this. All right, now we'll call this the center, and they say the max height is 44. What that tells you is this height is 44. Well, that's also your B value on a horizontal ellipse, okay? And then they tell me this coordinate right here, 22 feet at 9 feet from center. So right here, we'll say 9 feet from center, it was 22 feet high. That's an X, Y coordinate. So now you take your equation, x squared over a squared plus y squared over b squared equal to 1. We know x and y, so go ahead and plug them in. We know what b is. We need to go solve for a. So it's real similar to that other one that we just did. This right here is when you do it, it's going to have a value of 1/4 again. And so it's going to look like this, 9 squared over a squared plus 0.25 equals 1. Subtract that 0.25, and I'm going to go ahead and make 9 squared 81. We'll call it 0.75 over 1. You could call it 3/4. It doesn't matter. You're going to end up cross multiplying. You're going to have to divide by this 81 right here. And so you get a squared equals 108. You don't care what a is because remember your goal is an equation, and so it's just going to get squared anyways. So my answer would be x squared over 108 plus y squared over 44 squared, which is 1936, equals to 1. Okay, 2 more. We're almost there. Number 14. There's this roof with the shape of a hyperbola y squared minus x squared equals 20. And so they give you the equation. That's nice. And they tell you that this distance right here is 9. And they want to know this blue height. So you need to think of it as a coordinate. This is an x, y coordinate at 9, comma, y. So we need to go solve for that y. Well, if they gave you the equation, y squared minus x squared equals 20, just plug in your x, so y squared minus 9 squared equals 20, and then just go solve for it. So y squared equals 101, so y equals root 101, which is roughly 10, maybe like 10.05 meters. This would be my answer, or root 101 meters. That was an easy one. Okay, and then this last one. I see the word parabolic, so I'm instantly drawing a parabola. Okay. They have a cross section and it's 30 inches wide at the opening. So this entire distance is 30. And we're going to call this the center, the vertex at 0, 0. All right. So what that blue tells you is this is 15 from center. Okay. So they want, and then they also give you the focus, which is 9 inches from the vertex. So we know this right here, this red amount is 9. Well, that's your p-value because it's from your vertex to your focus. All right, so we know the p-value, and basically they want to know this depth of the flashlight, this green line, okay? So you got to make this an xy coordinate. You know the x is 15. You don't know the y. That's what you need to solve for. This is a parabola, which uses the equation x squared equals 4py because we're at 0, 0 at our center. And so now you just plug it in. So x was 15. So 15 squared equals 4 times p-value was 9 times y. So that's 225 equals 36y. So you divide and you get 225 over 36, which if you reduce that, you get 25 over 4. and they're talking in terms of inches. But if you wanted to make a decimal, that's 6.25 inches. That's this this green height, the depth of the flashlight. So, all right, there you have it. Those are how you apply these parabolas and ellipses and hyperbolas into word problems. So I hope this video helped.